Okay, and then the last reason that synthetic substitution is so handy is because we have what's called the remainder theorem, which says that if you take a polynomial and you divide by this linear binomial, right, then the remainder, so the number that we've been boxing off, is your function evaluated at that x coordinate. And we call that process synthetic substitution. So think about it. We have been saying from up above that if you have a polynomial, you divide by x minus k and get 0, then it is a factor. Well, that works because your remainder is 0. But if your remainder is not 0, then that just is what happens when you plug in that x coordinate. So, for example, we want to use synthetic substitution to evaluate our function at the given value. So think back to section 5.2 when we talked about direct substitution. And it was all this fancy phrasing where they basically just said, okay, use direct substitution to plug it in. Well, before we had to replace each of our x coordinates with 3, and we plugged it into our calculator. But this time we're actually able to solve it a little bit faster to confirm our results. So using synthetic division, you do not do the opposite sign of what you see for your number in your box. So you're going to put a positive 3 in that box. And then you're going to go, let's see, x to the 4th, x to the 3rd, x to the 2nd, x in our constant. Our coefficients are 2, negative 5, 0, x squared, watch out for that, negative 4, and 8. And we do our synthetic division. So bring down the 2, 3 times 2 is 6, negative 5 plus 6 is 1, 3 times 1 is 3, 0 plus 3 is 3, 3 times 3 is 9, negative 4 plus 9 is 5, 3 times 5 is 15, and 8 plus 15 is 23. So that is our remainder. And notice this time we are asked to evaluate. So before we were asked to identify the resulting polynomial when we were writing in factored form or when we did that division. This time we want to say what f of 3 is. Now we could have taken the time to plug in x equals 3, or with synthetic division, we know that if we did, we would get 23. And just to confirm, if you want to plug that into your calculator, 2 times 3 to the 4th minus 5 times 3 cubed minus 4 times 3 plus 8, we get 23. So let's do it again. Now we have g of x, and we are asked to find g of 2. So again, we could plug in 2 for x, or we could say that we've got x cubed, x squared, x in our constant. Our coefficients are negative 3, 1, negative 12, and negative 5. Bring down negative 3. 2 times negative 3 is negative 6. 1 minus 6 is negative 5. 2 times negative 5 is negative 10. Negative 12 minus 10 is negative 22. 2 times negative 22 is negative 44. Negative 5 minus 44 plus negative is a negative 49, which is our remainder, or in this case, it's what we get when we plug 2 into g of x. So notice that we could have done polynomial long division for everything that we did today. However, we saved ourselves a lot of time and effort and grief by doing our synthetic substitution and synthetic division. So go ahead, work through the homework problems now, and if you have questions, send them my way.